G'day everyone. Something I've wanted to do a video on for a while now is a complete build of a guitar pedal from start to finish. And the easiest way to do this, because there's different methods for building a guitar pedal. You can go the full-on do-it-yourself way and etch your own PCB, drill your own enclosure and all that sort of stuff. And you'll learn a lot from that. But if you're new and a bit intimidated to the actual hobby, it could be a good idea to start with something a bit simpler, which is where I'm going to start, which is a kit, a complete kit, something that you put together yourself. So you'll learn a lot from this anyway. If you don't know much about guitar pedals, or you're not familiar, or you're new to it, you should learn a fair bit from this, and just a general idea of what's involved actually building a guitar pedal. Now, this particular kit is one of my kits. It's based on my 7-minute fuzz, which is a popular kit that I sell, but it's a complete 7-minute fuzz kit, and I only made up about 10 of these last year, and to be brutally honest with you, they actually weren't that popular. The actual kit without the enclosure and the foot switch is more popular than these ones were, even though I was selling these pretty cheap. Go figure. I don't understand why, but that's the way it is. I got 4 of these left, so I'm going to actually build one and stick it on eBay pre-assembled, just to sort of move them and move on. So let's take a look at it. I'll open up the pack and show you what's inside, and it's a general. You can get these kits; they're all over the place, so it'll give you an idea of what's involved with any complete kit like this one. Before we do that, of course, we have to look at a few tools that you're going to need, and this is just a basic set. There's probably more that I'm going to use when I'm actually building the effect, but you can just see I've got some pliers, some side cutters, and a pair of wire strippers. You could use they're not. It's a bit rough, but you can use scissors instead of wire cutters. You probably may not need the pliers, and we also might need something to tighten up the nuts with. So some sockets or a wrench or something like that, or again some pliers, which aren't displayed here, but you'll see what you need as we go through it. And of course, something you have to have will be a soldering iron, because you can't solder a guitar pedal together if you don't have one. So this is the 7-minute fuzz kit, the one that I was selling, and I'll just show you what I was actually selling inside the pack. Oh, that's on tight. So inside we have the drilled enclosure, as you can see. There's a sticker from my web store, and the enclosure. Inside the enclosure we've got all the components. So there's a standard 7-minute fuzz kit. Those you can still get on my website. That just doesn't include the enclosure and the foot switch. You just got to source yourself one of those. I'm just telling you this in case you're following on and you actually got a 7-minute fuzz kit, because this could actually be pretty handy for that as well. They're the screws for the enclosure. This is the LED, and I've just put some heat shrink in there as well. You'll see what we need that for later. There's the knob, and there's the in-out jacks and the DC jack. So it all fits inside that one little neat package, which I thought was a pretty cool idea. But like I said, they weren't that popular. I don't know if I'll make any more of those up, because they've been actually quite hard to move for some strange reason. But anyway, let's move on to the assembly of the effect. So all this hardware put to the side. You don't need any of that yet. All you need is what's inside that packet, which is the PCB and the components. That's where we start. And you don't need the wire either, because that comes later on, or the battery snap, that also comes later on. All you're going to need to start off with is the components and the PCB and the potentiometer. Now I should also say I like to go into a lot of detail. I think people appreciate the sort of detail that I go into when I'm doing a video like this. Some people do, some people don't. Can't cater to everybody. I'm just trying to show you exactly the information that you need to know. So generally I like to assemble this in height order. So what that means is go with the lowest lying components like diodes, resistors, and then go up to capacitors and transistors, and then put the potentiometer on last. So if you are actually following the 7-minute fuzz kit, it's a good idea to actually bring up the build doc. So to get there, go to www.diyguitarpedals.com.au/shop, and then go PCBs and kits, and then go 7-minute fuzz, and then scroll down, and you'll see under downloads there is bill of materials and build doc on that one, and then that's where the bill of materials is. So that's the list that you follow when you are assembling this. So I'm going to print that off so that we can see it as we're doing it. So what does all this mean? Well, I could spend a video just talking about what it says on that sheet. So I'm just going to break this down to you very quickly. In fact, that could be an idea for another video to go over what a bill of materials actually means and look at it a bit more closely. But we're not going to do that for this one because it's going to make the video go for too long. It's basically like a paint by numbers sort of thing. It's telling you what resistor goes in what position. So R1 is the position, and the value, whoops, sorry, get that on the screen, and the value is 10K. So if we look at the PCB, we will see that R1, which is up the top here near my finger, you might be able to see it there, R1, that needs a 10K resistor in it. It's asking, that's what it's asking for in that position. And then you've got two capacitors, C1 and C2, and you'll find two capacitors on there, C1 and C2, and that's those two big boxes. You need to put the right value in the right position, as it says on the bill of materials, and so on and so forth. Diode is the BAT 41, which is the blue diode with the black stripe. Black stripe's the polarity, and a potentiometer, which is the volume control. Like I said, I'll go into a lot of detail, but I also don't want to make this video go on for too long because we actually have a fair bit to do. We've got to assemble the effect inside the enclosure as well. So I like to start with the lowest lying components first. So for this pedal, I'll put the resistors in first. It's just a good practice to get into. You don't have to do it this way, but I like to do it because sometimes you can get a bit tight and you can't actually fit everything onto the PCB. If you're doing it the other way around, you do the higher components first. So just bend, well, where am I? Here. Just bend the resistor legs at right angles and put it in the R1 slot. And then solder onto the back. I'm using 0.7 mil solder, and it is 60-40, which is 60% tin, 40%, it says it there, 60% tin, 40% lead. Not sure if you can see that again, but just like a small little mound is all you need. So if you're to look at the resistor, pretend that that's the two legs coming through the bottom, and this stuff here is the solder. This is what you want, not this mounded up, and not like a tiny little bit in the corners either. So just a generous amount, but not too much that it mounds up like that. And then using your side cutters, cut off the leads, don't cut off the solder. So the next one we'll do is a diode, and the diode actually has a polarity, as I mentioned before. It's got a black line on it. This camera has focusing issues. Actually, I should put up some white paper behind it. Has focusing issues when there's background, when there's a lot of stuff, a busy background. So yeah, you can see the black line on that. So that's the polarity, and the black line needs to line up with the line that is on the PCB. So in this case, it's the diode D1 there. You can see it's got a little line on one side. That's the polarity. So we put that into that position around that correct way. If you put it around the other way, the effect may not work. In fact, if you put any polarity around the wrong way, the effect might not work. So you just have to make sure that you put it in the right way. So it's the same thing as we did before. Just pop it through and put the leads at right angles. I've actually stuffed this one up because I've gone too close to the component, like that. And as you just saw, don't worry too much if it's not perfectly neat, it'll still work. So we'll do the capacitors next. And the bill of materials tells us that 1 microfarad goes into C1 and 100 nanofarad goes into C2. So I can tell you that 1 microfarad is actually the cream colored one, the bigger one, and 100 nanofarad is the blue one. And I don't want to go into how to read capacitor values because it can get pretty complicated, and we're going to get distracted from the point of the video. But I'll just say that 100 nanofarad is 0.1 microfarad. That's why it's so much smaller, and the 1 microfarad's so much bigger. It's 10 times, 1 microfarad is 10 times the size of 100 nanofarad. So that's the order that you can put these into the PCB. So yours should look something like that. I hope you can see what I'm doing in the close-ups. It's difficult to assemble and watch the video at the same time. I mean, yeah, probably following what I'm saying is more important than actually what I'm doing anyway. So that's the two capacitors. So we'll move on to the transistor next. And the transistor with this kit actually comes with a little socket. They're pretty handy to have in case you put the transistor in around the wrong way. They can be difficult to get back out again. Or if you want to experiment with the transistor and change it for a different one, you can. So I'm going to put the socket in. So just to show you what I mean, this is the socket. That's the position that transistor needs to go in. So instead of putting the transistor in, you put the socket in instead. And the socket's in a straight line. You can just pop it straight in like that. It'll fit without any manipulation, and then just solder that in. Just be careful when you solder that you don't make connections between the solder joints, otherwise your effect might not work. Some of them are close. You always have that situation, no matter which kit you're going to use. You're going to have some that are close together, so just be careful. So now we can put the transistor straight into the socket instead of soldering it in. So just open up the legs like that and slip it straight into the socket. Where is it? There. And make sure you put it the right way around. You can see on the actual PCB it shows you which way the right way around is. One side's round, the other one's flat. And if you look at the transistor, one side's round, the other one's flat. So just make sure. So in the video, if I was going to put it the right way around, oh boy, this is all backwards. I would go like this. You can see on the silk screen down here, the round hump at the top. Yep, goes in straight like that. You can also cut those legs down if you don't want it to be so tall. I'm just doing this in a bit of a hurry, so I've left it. The potentiometers are different for every kit that you get. Every project will use different sizes. Mine uses a 9mm one, which is nice and small, and it goes straight into the PCB. So it's actually called a PCB mounted potentiometer. So it will go in actually onto the back of that. That way, like that, and we just need to cut off these legs. But one thing I always forget, and I'm doing it again, is that you actually should put the wire in before you do the potentiometer, because it can get a little bit tight once the potentiometer, if you can imagine the potentiometer sitting on the back there, these wire holes become a little, well, particularly this one up here is going to become hard to actually solder into. So let's do that first. My length might be a bit smaller than what you'd be comfortable with, because I've done this many times. So I would suggest probably cutting it a bit longer than I do. But I'm just going to cut off a small length like this. And I'm going to use red, white, blue and black. This is just the way that I do my color coding. You can do it whatever way you like. But I usually use green and blue for input, yellow or white for output, and black and red for positive and negative. So that's why I need blue, white, black and red, like that. So I'm just going to cut off a small length. I'll leave a bit extra just to make sure that I cut it off long enough, because I can always trim it down later on. And then we need to wire strip those, and I've just got this automatic one over here, which I'll quickly do. Like so. You can tin those if you like. I don't usually do it unless I'm in a position where I'm having a bit of trouble. So just solder those in the order that I was just saying before. If you want to follow my color scheme, so blue will be input, yellow, white will be output, black will be ground, and red will be positive. Now, one thing I just thought I should mention, I actually go through the bottom because it looks neater once you put it inside the enclosure. If you can imagine the wires coming out the bottom as opposed to the wires coming out the top, it's purely an aesthetic thing. You do whatever is the easiest for you to do. You can do it the other way around if you want. It's not going to make any difference. It's just a neatness thing. Like that. And then we're going to put the potentiometer into the PCB. So as I said before, cut off the little tabs on this if you've got one like mine with the little tabs on it. I'm going to use some side cutters I don't care about for that, because these things can be quite tough. And then put a little bit of electrical tape on the back of that just to make sure it doesn't short, because as you'll see in a moment, it's actually going to touch the back of the PCB where all of the solder connections are. So just cover it up like that, like I've done there, with electrical tape or some sort of tape to stop it from touching the solder joints on the back, as I mentioned before. So now we can put the potentiometer in. So the potentiometer, as I was saying before, goes on the back of the PCB like that. So it's not on the component side, it's on the underside, the solder joint side, generally speaking. And it will go in like this, so that's what the effect's going to look like when it's done. And you'll see how that all fits together when we start putting it inside the enclosure. So I'll solder that in. So that's the completed effect, and it will make the fuzz sound that we want. It's finished in that respect, but obviously connecting your guitar to a whole bunch of flying wires like this isn't a convenient way, and there's no way to turn it on or off, so we have to put it inside the enclosure, and we put some aesthetic things on it like the knob and all that sort of stuff, paint work on the front, all that sort of stuff you can do. But it would be, I'm taking the title of this video seriously. It says complete process, and it would be kind of a little bit irresponsible for me not to include this next bit, even though it's going to make the video longer. You have to do this with every pedal that you build. You have to test at this point to make sure that this effect is actually working, because if you plow on and start soldering the effect inside the enclosure, you're creating a larger scope for error. You don't, if you do that and you wire it up inside the pedal and it doesn't work, now you've got all this extra stuff that you have to check to find where the problem lies. If you check it now, at least you know the PCB is working, and there's a high probability that the PCB is not the problem that you're having, it's actually the off-board wiring. So it's kind of like a process. You check at this point, and it's what the community call rock before you box, which is what we're going to do. So those of you that have watched my channel, you've seen me do this before. I have to include it. I know you're probably getting sick of seeing this, but it's so important, and people who are new to building pedals will be watching this video, and they really need to know how to do this. So in the build doc, there is this page, and of course you can use this page no matter what project you're doing. You're welcome to use it for whatever project you're doing. Print this off so that you've got a wiring diagram to test the effect. You have to test it now. Like I said before, it becomes very complicated later on if you've got a problem and you don't know how to fix it. So print this off and wire it up the way that it is here. Now, with this battery, you don't have to use a battery. You can just replace that with a DC jack. That's fine if you're using DC, and you don't need a stereo input either. You can use a mono. Just where you see ring and shield, just pretend that they are the same lug and put them together. A mono doesn't have a ring, it's only got a sleeve. So the negative from the battery or the negative from your DC will go to the sleeve instead of the ring. So as you can see here, I've got my jacks connected to the end of my guitar cables, and here's the effect. And I know, because I've wired this the way that I always do, I know which one's in, which one's out, which one's ground and which one's plus. You'll need some alligator clips to do this. Sorry I didn't mention it at the start of the video. It's just something that I thought of now. Sorry if I seem like I'm in a bit of a rush. The kids are out with their mum at the moment at the shop, so I'm just trying to get this video done before they return, before the chaos comes back. So let's just wire it up the way that it says there. So it's a simple matter of just following this. So you can start with ground. It's probably one of the more complicated ones. So I'll just use this. The black ones or the white ones for ground. So we go from ground, and then it says ground goes to both sleeves. So when you look at the jack, the sleeve, this as you can see, this lug here is connected to the tip contact. So that the tip's not the sleeve. up the guitar cable jack is the sleeve. So you can see that this, well, you might be able to see that this lug is connected to the inside of the jack, which is connected to the sleeve. So that's the sleeve. All you got to do is remember that that's the sleeve, that's the tip. So when it says connected to the sleeve, I'm just talking about that lug there, not the one on the other side over here. Hope that makes sense. You can use a multimeter in continuity mode to double check that, because your jack might not look the same as my jack and you might be a bit confused, but it's a good way. Usually you can just hold them up, look at them side on, and you can see the wafers. It's kind of like a wafer construction. You can just see what part of the lug and the tip is connected to what part of the actual jack. Hope that makes sense. So connect all those up to ground. So the only ones that are connected to ground both sleeves on the input jack and the negative from the power supply. So I'm going to use the mini DC that I've got that I had in the kit, and the negative, I know the negative on this is the small lug, so I'll connect that negative to here and plug that into onto the ground. So your hardware might be a little bit different to what I'm doing here. You might need to work out which one's ground and all that sort of stuff, but once you do, you'll be able to just hook it up the way that I'm doing here. Okay, so let's hook up the rest of these. So we might as well do plus while we're at it. So plus is obviously the red wire. So connect one alligator clip to the red, connect the other one to the long lug. If you're using my mini DC jacks, that's where it will go. If you want to use this hardware, I've got it on my web store as well. If you want to keep it simple and be able to follow along. So output is the white one. Now remember to connect this to the correct one. Don't connect it to your guitar input. It's got to be the output. So connect it to whichever one you've got connected to the output. Don't have your amp on at this time either. You're going to get all sorts of noise and pops, and don't want you to end up having some, like permanent ear damage. And so that one's the input, and that goes to blue, and I think that's pretty much it. So it's not overly complicated as far as the wiring goes. It's pretty straightforward. And when you're ready, you can turn the volume on the effect down, so it will be in a counterclockwise direction. Turn it down, and turn your amp volume down. Like I said before, you don't want to end up with permanent ear damage. So let's turn it on and see if it works. It's funny, actually, I just turned it on and I wasn't getting any signal. I was wondering why. Hadn't plugged the power in. It's just one of those things. There's a lot to remember. Don't freak out if it doesn't turn on straight away. You may have your transistor in backwards. You may not have put your power in. You may have swapped the input and the output. And do we have an effect? Of course we do. So I hope I've demonstrated the importance of rocking before boxing. You can move ahead with confidence knowing that your effect works. You can put it in your enclosure and you don't have to worry about the effect not working. You know that it works. Obviously, at this point, if it didn't work, you'd have yourself a problem and you'd have to fix it now rather than later. It's also harder to fix a PCB when it's inside the enclosure as well. So we can move on to the enclosure now, and we can put it in the enclosure and wire it up and wire it up true bypass with the LED and all that sort of stuff. So let's move on to that. I like to use this thing called a pan of ice. You don't have to, of course. You can just put it on your bench top. Just helps me to keep my neck straight and avoid headaches and things like that. So I'm going to put the hardware inside here. These enclosure videos are sometimes tricky to record because it's hard to show you what's actually going on, but I'll do the best I can. So with the 3-pole double throw, you put it on with this little, it's kind of like a locking washer. You put on the top, and then that goes in like that, and then the plastic washer and the other nut go on the other side. Don't worry about tightening it up at this point. It's not important. We'll tighten it up when we're finished and we're happy that everything's working the way it should be. And also I should mention at this point, if you want to do artwork on the front of your pedal, you have to do it before. Well, you don't have to do it before, but it's certainly a lot easier if you do it before you start wiring things up on the inside of the enclosure. I'm not going to do any of that, but if you want to do it, now's the time to do it. And I've got plenty of videos on what to do as far as that goes, all sorts of options. So the LED is probably going to be the trickier part of this, so we'll get that out of the way first. So with these metal bezels, you have this little, I don't know if you can see in this video, let me zoom in a bit for you. You can see there's this little plastic sort of plug on the end of it. That goes into the back of the bezel, which holds the LED down inside the bezel. So that's got to go on first, because once we start soldering wires and resistors and things to the legs of this LED, you're not going to be able to get that plastic plug back on. So do that. So put that on first, and then start following me with the actual wiring. So the resistor goes on the negative. Well, I put the resistor on the negative side of the LED. Apparently, electronically, you're not supposed to do that. You're supposed to put it on the positive. Never had a problem with it, and I'm just going to stick with it now because I'll remember, and I won't make a mistake. So the negative side of the LED is the one with the short leg. So that, or there's a flat side actually on the plastic, on the plastic housing of the LED. There's like a little flat edge. If just in case you're wondering which side the negative is, that is the one. So cut that short, and we're going to attach the LED to, the resistor to the LED leg. I use blue tack for this. It's good. It holds things in place for me, particularly with this tricky stuff where you need 3 hands but you've only got 2. And then cut the other side of the LED short like you did with the cut the other side of the resistor short like you did with the LED and the positive as well. And then we're going to attach a red wire to that side and a black wire to that side, because that's the negative and the positive, just so to remind ourselves which side is which. Now I've actually already run out of red and black, so I'm just going to use something that I'll probably remember. I'll just use white, green and yellow. So green will be plus, yellow will be minus. Sometimes you just have to improvise like that with colours. Make these ones long if you're not sure how long they need to be, just so that you don't. It's better to have it too long and then cut it short, than have it too short and not be able, and then have to attach an extra piece of wire to it or something like that, and doesn't usually work out very well. So that's where we're at this point. Obviously, if you push those 2 joints together and make a connection, the LED won't light up because you'll make a short and the current won't make it to the LED. So put a piece of heat shrink on one side or both sides just to stop that from happening, to insulate them from each other. So they end up looking like that, and then you can just push it straight into your bezel, and we're done with that part. Now we can put the potentiometer in. So just take off the nut and the washer, and it just goes straight into that hole there. And you can put it around. This is a pretty small piece of piece. You can put it around whichever way you think. Obviously, you can plan that on where the wires go, so what works out the best. I'm just going to stick it straight in like this for the moment, but I'll probably end up changing it. So I put mine in like that. The transistor actually fell out, which is fine. I'm just going to leave it aside for the moment, put it back in later, and I'll probably have to cut those leads shorter so it doesn't hit the back of the enclosure. So at this point we need some sort of wiring diagram, how we're going to actually wire this effect up, and that's also in the build doc. So it's a little confusing to see it in a black and white if you print it out in black and white. The actual original document's in colour, so you can see which wire is connected to which. So I encourage you to go and get that document or view that document and follow that. And it's just a matter of wiring everything up one piece at a time. Everything's labelled, and it's just like connect the dots pretty much. If there's a little hump on the wire, like you can see some of them have a little sort of a little hump, that means that the wire goes over the top, it doesn't connect together. And once you do this a few times, the first time you might do it, it might seem a little overwhelming, but you do it a few times and you get the hang of it. So I'm going to wire mine up like this, and then it's done. Okay, so unfortunately with the wiring side, there's not a lot I can show you like step by step. It's just a matter of wiring up wires pretty much. But I can give you a few tips. So if you're new to building pedals, leave extra wire. Just like I said before, if you cut it too short, it's harder to add wire than it is if you just trim wire. So just leave the lengths longer than what you anticipate you'll use. But you can judge also that you're not going to need a piece of wire that's probably going to be longer than that. I mean, you know, even if you snake it up around like I have, it's still only going to be around that length. So maybe a bit longer than the length of your enclosure should be long enough for any piece of wire. The other thing too is some of these connections have multiple multiple wires going into them, so make sure obviously that you don't solder one wire in and then you need to put another one in, because then it gets really messy. So get both wires up through the hole, solder them both at the same time. That's a beginner mistake. It's a mistake that I used to do myself. Yeah, I mean, you don't worry if it doesn't look neat like mine. I actually did this in a bit of a hurry, and I can make it look, you know, anally neat. But I just wanted to get this one done. Like I said, I'm in a bit of a hurry. But for you, being new, it's not going to look anywhere near as neat as this. There'll be wires and stuff everywhere. Don't worry about neatness. Worry about reliability and functionality. Just make sure the thing works properly. So, just a few tips for wiring. So I'm going to put the knob on the front of it, and then we can go and test it, make sure that thing actually works. So there's only 2 tests we need to do here, and that is make sure that the clean works, clean signal works, and make sure that the effect works. LED works as well, obviously too, so let's make that 3 tests. So let's just quickly check it. There's clean signal. Turn the volume down on both your amp and the pedal, switch it on, and then slowly turn up the volume on your amp. Oh, hang on, we've got to put a bit of volume on the actual effect as well. And there it is. So that's it. That's the total process from start to finish with a simple pedal like this. I know if you're coming to this hobby it might seem a little complicated, but once you get into it and you break it down into steps like I did in this video, you'll be able to get your head around how to actually assemble, how to assemble effects. Then you can build almost whatever you like. You can build anything. This is a very simple effect. It's a good one for a beginner. So I hope you found this video interesting. I know I'll probably get a few comments about it being too long, too much talking, but it just has to be with a subject like guitar pedal building. It's a complicated, it's a relatively complicated process, or it's not so much complicated, but it's in depth, and there's a lot to talk about. So anyway, thanks for watching, and don't forget to subscribe, and I'll see you in the next video. Cheers.